Alright, this is part 2 of our lesson on solving and graphing polynomial inequalities. In this lesson, we will be graphing cubics and quartics as well as quadratics if they come up. But the new thing is several of these will not be factorable, and several of these will have irrational zeros. So you won't be able to find them on your TI-30, and it won't be factorable. So if that happens, we'll have to use other techniques, including technology like Wolfram Alpha we'll use in certain cases to find the zeros. If you have a graphing calculator, you could use that. Alright, let's start by getting 0 on one side. So I want to subtract x from both sides. Okay, so far that's going to give me x to the third power. Those cancel out, so x to the third power is less than or equal to 1. Okay, and then I'm going to subtract 1 from both sides. Okay, so that's going to give me x to the third power minus 1 is less than or equal to 0. Okay, so this is the function that we're going to deal with right here. Alright, this is factorable. Okay, because this is the difference of two perfect cubes, and we did learn how to factor that a while ago. We learned that this would always factor as a binomial and a trinomial. Okay, let's bring this back into your brain. The binomial is just the cube root of these, so this will just be x and minus, and the cube root of 1 is just 1. So the binomial is x minus 1. For the trinomial, we can get the beginning and end of the trinomial by simply squaring these. So if I square this, of course, I'm going to get x squared. If I square this, I'm going to get positive 1. Okay? So all that's left is the middle. Alright, to get the middle term, I'm going to multiply these together. So x times 1 is just x. Alright, but it will always be the opposite sign. So this was negative, so this will be positive. Alright? Now, normally we would try to factor this more, but when we use this method, when we factor the perfect cubes, this trinomial will never be factorable. Alright? We might even try using the quadratic formula, but these will turn out to be imaginary solutions. Okay, so they're ungraphable. So we only have, in this case, we have one real 0, and that's it. Just 1. Okay, and that 0 comes from, of course, setting this x minus 1 equal to 0. So we have a 0 of x equals 1. So that is our only 0. I'm going to go ahead and solve this using the test value method first. Then I might quickly show you the graph as well, because it's pretty quick. Okay, but using the test value method, we'll graph our 1, 0. So let's see. So I like to include 0 on here, so I've got that. And then my 1, 0 is at 1. Okay, am I going to do an open circle or a closed circle? Yeah, closed circle, because I want to include the places where it's equal to 0. And this is one of those places. This is where it's equal to 0, but that's included. So closed circle. Okay, so this 1, 0 divides the number line into two zones. Alright, we have the yellow zone on the left, and we have the blue zone on the right. Okay, so test values. Let's talk about what test values we're going to use. keep doing that by accident. Okay, and you know, I'll make the little chart like I used to do. Alright, in the yellow zone, let's use 0 as a test value. Okay, in the blue zone, let's use 2. Alright, just keep it simple. Alright, so these will be my two test values. Alright, so I'm going to plug those in. Okay, so I'm using this function right here. So I have x to the third power minus 1. Okay, so that would make this, okay, so look, I had x to the third power minus 1 is less than or equal to 0. Okay, so that would make this 0 to the third power minus 1 is less than or equal to 0. Okay, 0 to the third power is just 0, so that just makes negative 1 is less than or equal to 0. Is this true? Yes. Negative 1 is less than or equal to 0. That means 0 is a solution, alright, which means all of these yellow values are solutions. And I will show that by drawing an arrow in, representing all of those yellow values. Okay, so we have solutions on the left. Okay, now on the right, let's test f at 2. Alright, but again, we're talking about x to the third power minus 1 is less than or equal to 0. So that means 2 to the third power minus 1 is less than or equal to 0. Okay, so 2 to the third power, that's 8 minus 1 is less than or equal to 0. But that's 7 is less than or equal to 0. Is 7 less than or equal to 0? No, it is not. That means 2 is not a solution, which means none of these blue values are solutions. Okay, so we will just leave that blank. Alright, therefore, this is the graph of the solution set. Okay, this is the answer. We're going to want to go ahead and make an interval, and this is negative infinity to 1. And I'll just use a closed bracket to include the endpoint. So that's the answer right there. Okay, so that's a good one to do by test values, because there's only 2 of them. You can pick integers. It's easy to do. Alright, take a look at number 4. Let's start by getting 0 on one side, so let's subtract x from both sides. So that's going to give me x to the third power. These are like terms, so this is going to make negative 4x is less than or equal to 0. Okay, so this is the function that we're going to deal with from now on for the rest of this problem. Okay, so let's try to factor it, alright, because I see we do have a common factor of x, so let's pull that out. If I pull out a common factor of x, that leaves behind x squared minus 4. Okay, I didn't really need to change color, so x squared minus 4 is less than or equal to 0. Now this will factor further. This is the difference of two squares, so x plus 2 times x minus 2 less than or equal to 0. Okay, so I can get my 3 zeros by setting these 3 factors equal to 0. Right? Again, I know I'm going to have 3 zeros because of the degree. So setting the first factor equal to 0 gives me one of my zeros. Okay, if I set x plus 2 equal to 0, that's going to give me a 0 of negative 2. And if I set x minus 2 equal to 0, that's going to give me a 0 of positive 2. So here are my 3 zeros. Okay, I'm going to go ahead and do this one by the graphing method only. Okay, the graphical method. So for the graphical method, I'm going to need 2 graphs, one for my work and then another one for my final answer. Okay, so this will be my work graph. So my zeros are, I have a 0 at -2 and 0 and positive 2. These are my 3 zeros. So this is where the function equals 0. Okay, at these 3 points, the function equals 0. Okay, now looking back at this function, this is cubic and it's a positive leading coefficient. So in general, we're expecting this sort of N shape of the graph. Okay, and we've got 3 zeros, so it should be able to make a full N shape through this. So let's go ahead and just sketch that. Okay, so it's doing like this. Okay, not a perfect graph, but you get the idea. Okay, now we want the parts of the function that are less than or equal to 0. Okay, so that means below or equal to 0. So because of the equal to 0 part, I'm going to include these endpoints, alright, because this is where the function is equal to 0. And I'm going to include the parts that are below, meaning below the x-axis, below 0. So this is below, and this part of the graph is below. Okay, so now for my final answer, all I want are the x values. So I'm going to come over here to my answer area and draw another graph for these answers. Okay, so I have my same zeros of -2 and 0 and positive 2. Okay, when I do this graph, I like to put the points above the number line. So these will be closed circles. Alright, because we want to include where it's equal to 0, and these are the equal to 0 points. Now we find our solutions. Our first interval where we have solutions are everything to the -2 and to the left. Okay, so I will show that with an arrow going to the left. And then between -2 and 0 we have no solutions here, but then we have solutions from 0 to 2. Alright, so I will show that with a segment from 0 to 2. And that's it. Beyond 2 there are no more solutions going to the right. So this is our actual graph of the solution set. Of course we're going to need a couple of intervals here. So on the left, this is -∞ to -2. It's got to be in that order. I'm going to use a square bracket to show that we're including the border point. And then union, and then an interval from 0 to 2, again with the square brackets to include the endpoints. Okay, so this is the complete answer to problem number 4, I think this was. Alright, that's it. And let's go ahead and stop this video here, and we'll pick up the next video will be number 5 and number 6.